So next, let's look at this question here, which is on application of integration. Let's see how I can do this proficiently. So you're given the curve C with this equation here, from -1, -1 to 1. The region R is enclosed by C. The x-axis and the line x equals -1 and x equals to 1. Find the exact value of area R. Okay, the first thing I think what we could do is actually just try and figure out what is the, how does the graph look like. You could just key in -1 to 1 first. So this case here, this will be 1 over square root 4 minus x squared. Okay, then you just graph it. So obviously you just want a -1 to 1, the range here. So it looks like that. After which you're told that actually the region R is enclosed by C, the x-axis, the line x equals to -1 and 1. Find exact value of R. So this case here, what I'm going to do is I'm going to trace and put a 1 here. And this is this value I need to find. This I need to find. So I think that's pretty okay. Maybe I should just window, just zoom in a bit. So this case here, I'm just going to put this as -1. Just graph it first. It looks something like that. Then hold on. So here what we can get is actually just put it down. This is x equals to -1. X equals to 1. So this case here will be here. So what I'm going to do is actually to find the exact area of R. This is my R. Because you are told that enclosed by C, which is this, the x-axis, x equals to -1. So it's just a simple integral here. So this will just be -1 to 1. Okay. 1 over square root 2 square minus x square dx. After which you're just going to use the MF26 to find the value there. So bring out MF26 and you will find a square. So sine inverse x over a. So this is sine inverse x over a. A is root 2, so sine inverse x over 2. And this is 1 and -1. I think that is pretty okay. So once this is done, you get sine inverse half minus of sine inverse -half. Okay, sine inverse half, what we'll get is actually 30 degrees, right? So this is actually sine inverse half is 30 degrees, so meaning to say this is pi over 6 radian minus this will be -pi over 6. Okay, because it's in the 4th quadrant, so you can just put a negative here. So this will be pi over 3. So there you go. So square units, you can just put square units there. Great, so this is how you do the first part here. Okay, let's look at part 2. Part 2, you are told to find the exact volume generated by R rotating 2 right angles about the x-axis. 2 right angles about the x-axis, meaning we need 90 degrees times 2, which is actually 180 degrees, or pi radian. So in other words, you need the volume. You're not revolving, if it's about the x-axis, you're not revolving 360. Okay, so the volume that is required of you is something like that. So if you look carefully, so it is just 2 right angles. So meaning we are looking at, ouch, here, just 180. Okay, so let me see whether I can just put this as 180. There you go. Yeah, so 180. Something is wrong with my so if I follow this, yeah. So this is 2 right angle. Okay, just assume that there's nothing down here. I'm not sure why it's protruding. So yeah, something like that. Okay, just assume that there's nothing below here. So this is 2 right angle. We do not want to be 360 entirely. So there you go. Okay, like that. All right, so what we need now is actually we don't take 360, but we take whatever we revolve about 360 degrees about the x-axis, we just divide times half, right? So that's what is required of us. So this case here, when we are doing this part 2, we will get basically the volume generated is basically just half of it, so it's just something like that. Okay, and what we need is actually just pi, half of pi, -1 to 1, y squared dx. That's about it. So y squared, we're just going to square that, and that will give us minus pi. This is -1. Square root of 4 minus x squared dx. And that will give us half pi -1, 1. And this is 4 minus x squared 1 dx. Similarly, I'm going to put this as 2 square. And I'm going to use my MF26 to tell me which formula I need to use. I ought to use the second one. Okay, where mod x is less than 2. So this case here, I'm going to get as half pi ln, is it 1 over 2? A is 2, right? So a is 2. So this is 1 over 2 ln 2 plus x, 2 minus x. Great. Okay, so there you go. So once this is done, we're gonna get 1. So this is 1 over 8 pi on the 3 over 1 minus of ln 1 over 3. Okay, so when we do this, so what I did was I just take the 1/4 out, right? That will be easier. So this will be 1 over 8 pi ln 3 minus ln 3 -1. So this half, just -1 could bring down. So this will be ln 3 plus ln 3 with 2 ln 3. And that will be 1/4 pi ln 3. Okay? And this is cube units. So that's how I do this question here proficiently. Any question or comments, please let me know, okay? So let's continue on with part 3. Part 3, we are told to rotate this about the y-axis, 2 right angles. 2 right angles meaning 90 degrees times 2. Same thing with what we did with the previous part, which is we just need one. We don't need the full rotation. So if you could see, is something like that. Just 180 revolve about it. It's just half of it, right? Yeah, but I could model it out for you. So this is important because this is something which I think sometimes students get confused. There's a cylinder involved here. So I'm gonna just quickly rotate and show you. So if I were to rotate this about 180, about just 180. Okay. Whoa. Okay, let me see. 180. Okay, yes. 180 will mean that actually you're going a full 360 degrees, right? Because this what do you call it? You could see that as you rotate 180 of it, it becomes a 360 diagram like that. I'm not sure why this is rugged, but yeah, you get the idea. So there's this dent here that you need to minus off. Okay, so I need to explain part 3. Volume generated. You need what do you call it? To minus off this portion here. Okay, this dent here is important, so that it will you take the cylinder. Okay, cylinder here. Minus off the top part, which is like the small dent on top, if you can visualize it. Okay, so I hope you can. This would be 1 unit. Then this will be a height here, which is 1. This here you could find a height. So when x is 1, this is 1 over root 3. So obviously this is 1 over root 3 here. This is 1, and just sub into the equation y equals to 1 over 4 minus x squared, right? Yeah. So it's 1 over root 3, and after which, same thing. Okay, and this would be negative 1 over root 3 as well. Great. So once that is done, then this part here, this cross section here will be 0 and 1 over 2. Okay, that's 1 over 2 there. Great. So what we need here is essentially taking this more than here. You need to minus off this, because when you integrate with respect to y, this curve, you're actually getting this this portion here when you project on the y-axis. Okay, so this small portion here is a very annoying one piece, which is this part here. So here, this is a cylinder. The outer, this whole thing is a cylinder. So I'm going to take the cylinder. Cylinder would be 1 over root 3 here. So this is 1 over root 3, of which the r is 1, which is here. Okay, and that's about it, I think. And after which we have got root 3. That's 1. Okay, so this would be pi r square, which is the radius, and the height 1 over root 3, minus of this would be pi from half to root 3, 1 over root 3, y square, x square dy. Okay, so I get to find out what's our x square, make x square the subject. So this will be square root 4 minus x square equals 1 over y. 4 minus x square equals to 1 over y square. X square equals to 4 minus 1 y square. Okay, so this is 4 minus y square. So pi root 3, 4 minus 1 over y square. Is it 4 minus, yeah, there you go. So this shouldn't be a problem, I think. I think should be fine. So this is y. 4y. Okay, integrate straight. This is 4y minus y minus 1. Okay, so this case here done. There you go. It's a lot of, oh my goodness, a lot of things going on here. So let's see how we can, we need it in root 3, right? So this is surds. I could just multiply bottom with root 3, top with root 3. I think it's not really an issue here. So this will be 1 over, this is root 3 over 3 pi minus pi, 4 over root 3 plus root 3 minus 4 times half, which is 2, plus 2. Same with this. Multiply root 3, multiply root 3. I could get 1 root 3 pi. Be 4/3 root 3 plus root 3 minus 4. So this will be 7/3 root 3. Okay, maybe I'll factorize out the pi out. It'll be easier. 1 root 3. 4/3 plus 1 would be 7 over 3 pi root 3 plus 4. Okay, there you go. So the thing about showing question, I love it, is because you can check answer. So this is 4. Hopefully that's the answer. Yep. 2 root 3. Yes, correct. So there you go. 4 minus 2 root 3 cube units. Yeah, that's how we do this question here proficiently. Any question at all, please let us know. Keep practicing and I'll see you in the next question.